Hi, so let's continue from where we ended when we looked at the introduction to Euler equations. You can check out the link of the introduction in the description below. Okay, yeah. So actually, after you have finished watching these videos, you can in the description below there is a link for the PDF where I solve these questions. Like I solved them, so you can actually go through it after you finish watching these videos. Okay, so what's going to happen now is that let's start with the first one. Let's start with the first one, which is A. I think I'll just solve two. Okay, so I'm going to pick A. So A, we are given this one here. Okay, how do we then solve it? So here it's just a matter of remembering what your y is, what your y prime is, and what your y prime prime is. So we say our y is equals to x to the r, then y prime is equals to uh, r by x to the r minus 1, then y prime prime is equals to r by r minus 1, then multiplied by x to the power r minus 2. So it's just a matter of substituting here. Okay, so that would be like x squared here, then I'll put these brackets. So where I have y prime prime, I'm going to put r, then I have like r minus 1 by x to the power r minus 2, then that would be minus 4x. I put the brackets there, which is then I have like my y prime, which is r x to the power r minus 1, okay, plus I'll say 4, then y, which is x to the power r, is equals to 0. Okay, so it's just a matter of now distributing this x squared inside and that x inside there. So this would be like r, open bracket, r minus 1, then that would be x to the power r minus, that would be 4r x to the power r plus 4x to the power r is equals to 0. Okay, so what does this now become? This actually just simplifies to, you can have like your r minus 1 minus 4r plus 4, then you have like your x to the power r is equals to 0. So remember to say in the introduction we talked about assuming that x to the power r is not equals to 0. So simply means what I have here I can equate it to 0 so that I can solve it as a quadratic. So this is r minus r multiplied by r minus 1 minus 4r plus 4 is equals to 0. So you can expand this part, that would be your r squared minus r minus 4r plus 4 is equals to 0. Okay. Then this one would be like r squared minus 5r plus 4 is equals to 0. So we can actually factorize this one. The product is 4 and the sum is minus 5. So I think I'm just going to use 4, 1 and 4. Okay, so it so happens to say this was like minus 1 and minus 4. When you multiply to say minus 1 by minus 4, you get positive 4. Minus 4 minus 1, that's going to be minus 5. So this would be like r squared minus r minus 4r plus 4 is equals to 0. So this would be like r, open bracket, r minus 1, then you have like minus 4 there, then that would be r minus 1 is equals to 0. So here it so happens that our values of r, okay, our values of r, r1 is equals to 1, then r2 is equals to 4, like that. Okay, so now looking at the nature of the values of r that we have, these are real distinct roots. Okay, so we know the general form. Okay, the general form is y of x equals to c1, okay, that's just a constant, multiplied by x to the power r1 plus c2 by x to the power r2. Okay, so now we could have just written 1 there and the 4 right there, but we have to find the value of the values of c1 as well as c2. Okay, so because we are given initial conditions, this is an initial value problem. Okay, so we'll come back here and say, okay, I have y of x is equals to that, so y of 1 is equals to, so this is like c1. Okay, then I'll say open bracket, my x is what? X is a 1. I'm picking the value that I have right here. My x is a 1. Okay, 1 to the power what? R1. What is a R1? It's a 1 plus. I'll say C2. Okay, C2. Then I have like 1 here to the power R2 is a 4. Okay, so remember to say this is equals to, I'm equating it to 4. Okay, I'm equating it to 4, so this is equals to 4. So you can just simply say C1 plus C2 is equals to 4. That's the first part. So remember to say you also have y prime. How do you get your y prime? Just differentiate what you have here. So this would be like y prime of x would be equals to, this would be r1 by c1, then x to the power r1 minus 1 plus, this would be r2 then c2 by x to the power r2 minus 1. So here this would be y prime of 1 because of this one that I have right here. Okay, so this would be equals to, my r1 is a 1, that's just like c1 there. Okay, that would be a c1. So for this part here, okay, for this part, this would be like when you plug in 1 here for x, then you say 1 minus 1, it would be 1 to the power 0, which is a 1, so I can just leave c1 on its own like that, plus then this will be r2. My r2 is a 4. Okay, my r2 is a 4, then I'll put c2. So if you plug in 1 here, then you say r2, which is a 4 minus 1, that would be 1 to the power 3, which is still a 1, so I can just leave it like that. And this is equated to what? This is equated to 13. Okay, so you have a system of equations that you have like your c1 plus 4 c2 is equals to 13. So what can I do here? I can choose to eliminate c1 here like this. Okay, so this is going to be if you say c1 minus c1, that would be a 0. Then if you say c2 minus 4c2, that would be minus 3c2 is equals to, if you say 4 minus 13, that would be minus 9. So it so happens to say your c2 is equals to positive 3. Okay, that is equals to positive 3. So I've determined to say our c2 is equals to positive 3. So now we can use any of these equations to come up with the value of c1. So it so happens to say if I pick this one, okay, I'll say my c1 is equals to, I'm just making it the sub of the formula, it will be equals to 4 minus c2. So that would be like c1 is equals to 4 minus c2, which is a 3. c1 is equals to a 1. So c1 is equals to 1 here. If you are to pick the other one, you're still going to get this the correct value for c1. If I pick the second one, which is c1, which will be equals to 13 minus 4 c2, this would be like c1 is equals to 13 minus 4 multiplied by c2, which is a 3. That will be c1 is equals to 13 minus 4 times 3 is a 12, which still gives you what? A 1. So that's correct. So we have everything that we need. So all we have to do right now is just to write the what? To write the solution, the general solution. Therefore, the general solution y of x is equals to our c1 is what? Is a 1. You don't have to put it. Then that would be your x to the power r1. What is our r1? Is a 1 plus c2, which is a 3. Then you're going to put your x to the power r2, which is a 4. That would be x to the power 4 like that. And this right here is the solution that we were looking for. Okay, and that's how you do it. Okay, so let me look at one more example. We have 3 examples. I'm just going to look at 2. You can take a look at the solution for the other one that I'm going to leave in the PDF that I'm going to put in the description below. Okay, so let me look at C. Okay, let me look at C. So for C, this is also quite straightforward. We already know to say our y is equals to our y is equals to x to the power r, then our y prime is equals to r by x to the power r minus 1, then y prime prime will be equals to r by r minus 1 by x to the power r minus 2. So here we have like 4 4x squared. I'm trying to take this step by step. I can actually skip all these steps, but I'm just trying to take it step by step. I have no reason to rush. This is not a test or a quiz, an exam or something. Yeah, so my y prime prime is r, then r minus 1, then x to the power r minus 2, then I have like minus 4x. In the brackets I have y prime, which is r x to the power r minus 1. Then what else do we have? Minus x to the power r is equals to 0. So you can do the distribution here. That would be 4 r, then you have like your r minus 1, x to the power r. So it's like it becomes more like a pattern to say whenever you expand here, this is what you're going to end up with on this part. Yeah, so you can actually see it even before you do anything, which is interesting. So this would be like 4r to the power, so sorry, 4r by x to the power r minus x to the power r is equals to 0. So we observe that x to the power r is actually common. So this would be like 4r, then that would be r minus 1 minus 4r minus 1. That would be x to the power r is equals to 0. Same assumption, x to the power r is not equals to 0. So here you can actually expand this. So that would be like 4r squared minus 4r minus 4r minus 1 minus 1, and this is equals to what? This is equals to 0. Okay, so this happens to be 4r squared. That would be 4r squared that'd be 4r squared minus 8r minus 1 is equals to 0. So I believe on this one we are going to get we are going to have the type of roots that you're going to have. They're not going to be, because I don't think I can manage to factorize that one. I don't think it's even factorizable. So I have a feeling this is actually going to give us something that is let me see. We're going to get complex roots on that one, but let's just attempt and see what we're going to get anyway. Okay, so that's what we end up having. I'm unable to factorize that one. Let me see if I can use the formula to come up with the values of r. Okay, so here I'm going to say I have like x to the power I have like 4r squared minus 8r minus 1 is equals to 0. Okay, so for this one, like for me to get the value of r, let me say r is equals to minus r plus or minus the square root of just using this quadratic formula, that would be not r but there but b, sorry, minus b plus or minus the square root of b squared minus 4ac divided by 2a. So that'll be like r will be equals to our b is minus 8. So when you say minus 8, that will be positive 8 plus or minus the square root of b squared is 64, which is like 8 squared is 64, minus 4 times our a, which is a 4, times our c, which is minus 1, divided by 2a. So our a is a 4, so that will be 2 times 4, that will be 8. So r is actually equals to our r is equals to, we're going to say 8 plus or minus So this would be like 64 minus this would be positive. So 64 plus 16, because 4 times 4 is we have 64 plus 16, that's going to give us 0. That would be 7, that would be 8, so we're going to get 80 there. So the square root of 80, square root of 80 divide by 8. Okay, so this is pretty interesting. So let's see where this takes us. So here is just a matter of finding the value of r. Okay, so that's what we have. Let's see what we're going to get. So you say our r is equals to 8 plus or minus. Let me try to simplify that one. 16 times 5 is actually 80. Okay, and I know the square root of 16 is a 4, so this would be like 4 root 5. Okay, divide by 8. Okay, that's actually interesting. It has it looks way better that it's simplified compared to the way it was as the square root of 18. Okay, so there's no harm to use decimal places. Actually, if you check the PDF in the description below, I used decimal places. So for r here, okay, this can actually be simplified further again. Okay, so I can write this as 8 divided by 8 plus or minus 4 root 5 over 8, of which this just happens to be r is equals to 1 plus or minus root 5 over 2. Okay, what's interesting about this is that we can just write our r1. r1 is equals to, that would be 1 minus the square root of 5, square root of 5 divided by 2. Then our r2 will be equals to 1 plus the square root of 5 divided by 2. So we have our values of r. So one thing that we observe is that these actually these are also real distinct roots. Okay, these are also real distinct roots. So the solution is still in the form y of x is equals to c1 by x to the power r1 plus c2 by x to the power r2 there, like that. So we have already found r1 and r2. It's just a matter of plugging them in, but we have to evaluate because this is an initial value problem. So we have to evaluate so that we find our c1 as well as what? As well as c2 there. Okay, so one thing that you're going to do here is that you can use the steps that we used in the previous example, which is this one. And what you're going to find in terms of decimal places, okay, it's a very long process. Not really that long, but it's interesting, but it's long, a bit long. Is that your c1 is going to be equals to what I found as my c1 in terms of decimal places. It was like 1.731. Then c2 was equals to, I didn't want to use fractions, so I got 0.029. That's what I got. Okay, it's very simple. Just plug in, just evaluate at that point. So just keep in mind to say, when you say y of 4, this will be equals to c1. Then where this x there, that you're going to plug in what? 4 to the power r. What is your r? Your r is this one here, and I was using decimal places. Actually, I didn't want to use fractions as they appear. So that's what you're going to get. And so you just write your solution to say y of x, which is the general solution, will be equals to your c1, which is 1.731 x to the power r1. So my r1, I can write it as 1 minus root 5 over 2, like that. Then plus c2, which is 0.029 by x to the power r plus root 5 over 2, and that will be your solution. So just try to work it out, and those are the values of c1 and c2 that you're going to get. You can also check out the PDF in the description below, which shows each and every step that I was taking when I was finding my C1 and my C2. So that's how you answer those questions. You can actually check out the solution for C as well. You can solve it on your own, then you can go to the PDF and make a comparison. So that's all in this video. Thank you very much for watching.